Guys, welcome to my YouTube channel. You are watching ETA. So if you haven't subscribed to my YouTube channel, please do so. And don't forget to like and don't forget to click the notification button so that you can get more content. Guys, I'm going to be teaching you guys a very interesting topic in mathematics. I'm going to be teaching you guys finance or financial mathematics. Finance, growth, and decay. Right. This is one of the most interesting topics. I love money, guys. So that's why I chose to teach about money today. It is very important to know how money works. So we're going to be talking about investments. So each and every time when you invest to earn interest. Now, there's two different types of interest that we're going to talk about. We have simple interest and compounding interest, which we're going to talk about later on. So with simple interest, your amount is given by the principal amount. This is the initial amount that you invest. The initial amount that you invest plus. So after a while, your investment will earn interests. And those interests are a product of I interest. And they also depend on the number of terms that your investment has earned the interest. So this is equal to, if you take out the common factor, you will have yes, that is it. All right. We also have compound interest. Which with the compounding interest, let's say for instance, if you invest P initially, at the end of the first term, you are going to get times N. Times 1. So after the first period, you're gonna get 1. And then after the second period, the very same investment, you're gonna get times 1. If you take the very same amount and invest it, it's gonna get that interest. Then if you reinvest the same amount, you're gonna get. So this is what you're gonna get. Like you're gonna get all this up to infinity. So what you're gonna get in this equation is P into, as you can see, up to the nth value. you're gonna be getting all these 1 plus interest terms times each other. So up to the value of n, you're gonna multiply n terms, if you agree with me. So that's the formula for compounding interest. Now, it is very important to master the timeline. Timeline starts from T0 up until Tn. All right, now let's dive into it. Okay, we have the so-called annuities. Annuities. What are annuities? With annuities, we're gonna talk about repeated amounts that are paid each and every month. So this can either be an investment in which each and every month you put a certain amount, or a loan which you have to repay a certain amount. So we have sinking fund, or loan. That's what we're going to talk about the most. All right. Now, the future value, if you are investing, the future value, the money that you're going to get in future, is given by, let's say, if you, it is given by, okay. And let me start by drawing a timeline. T0. Let me start by drawing a timeline. All right. T0 up until Tn, for instance. If you're investing at T0, you will put a certain amount. T1, you put another one. T2, you put another one. T3, you put another one. Up until T of n. Up until Tn. However, on the last payment, you don't pay. We just want to see how much money you're going to have if you're investing each and every month. So what is going to happen is that your first payment will accumulate actually, let's say your last payment actually no, let's say if I do invest on the last month as well, sorry. So your last payment, the money that you're gonna have at the end of your investment will be your last payment plus this amount will earn the following profits. 1 plus, I think you will agree with me on that one. Then plus the one that is following that one will earn x to the will earn x into 1 plus I to the power of 2 plus x into 1 plus I to the power of 3 up until that last payment. So that last payment will end x into 1 plus I to the power of n. I think you will agree with me on that one. Now, this is a geometric series if you look at it. So with geometric series, we know that the sum is given by a into r to the power of n minus 1 over r minus 1, provided that if your r is greater than 1, which in this fact our r will be greater than 1 for sure, because that's 1 plus something over 1. So we are sure. That's why we can use that formula. All right. Now, what is the value of a? The value of a in this matter will be your first term, and your first term is x. All right. Then what is the value of r? The value of r is, if you divide the second term, divide the second term over the first term, we're gonna get I by 1 plus I. All right. Now, the sum of all that, which is the future value, is given by x into your r is 1 plus I to the power of n minus 1, then divided by your r is 1 plus I, then minus 1. Then we are left with all right. Now, this is the formula of calculating the future value if you are investing each and every month, provided that you also paid or you also invested in the last month as well. All right. All right. Now, let's say we said we're going to talk about sinking funds or investments, investments for future. And also we're going to talk about present value, which are loan repayments. Loan repayments. All right. Now, again, we're going to have a timeline. T is 0 up until Tn. Right. With loans, normally you start paying the loans, at the end of the month. You also pay here as well. All right. Tn minus 1. All right. Now, the future value is given by the present value into 1 plus I. Now, let me yes. Future value 1 plus I to the power of n. Now, the present value is therefore equals to the future value over 1 plus I to the power of minus to the power of n. This is given by future value multiplied by 1 plus I to the power of n. So this one, let's see, it's we are repaying loans each and every month. So this is the amount that we are paying each and every month. Each and every individual payment will accumulate interest. Made a mistake, that's a minus n. All right. Now, so the present values are given by, if we add all the payments with the interest, you'll see that because present value is like the reverse of the future value, we will have the following. That payment day will accumulate interest. So we're gonna have something of this sort. Minus 1. All right. Then plus x into the second payment will accumulate interest as well. The accumulated interest will be minus 2 plus, and the third one will be minus 3 up to x x into 1 plus I to the power of n, which is that value right there. All right. Again, if you look at it, this is a geometric series whereby the sum n is given by a into 1 minus r to the power of n. Sorry, my bad. All right. Provided that if r is less than 1. In this case, r will be less than 1. So we have a into 1 minus r. So your a will be x into 1 plus I to the power of minus 1, which is equals to 2x over 1 plus I. Then it's fine. Right, and your r will be first term x into 1 plus I to the power of minus 2 over x2 1 plus I to the power of minus 1. Right. This is the value of R. So this will be 1 plus I to the power of minus 2 minus 1. This will be 1 plus I to the power of minus 2 plus 1, that is minus 1. All right. Moving right along, we will have the following. 1 minus, in brackets, we have 1 plus I to the power of minus 1 to the power of n over 1 minus, in brackets, 1 plus I to the power of minus 1. All right. We go down. This will be A into 1 minus 1 plus I to the power of minus n. Right. The numerator is solved. Now we go to the denominator. No, I made a mistake. Sorry, guys. Yes, but we still, I didn't replace the value of A. Now the value of A is given by that is x over 1 plus I times that. Now, we will have the following. We will have x over 1 plus I times that, all over 1 minus 1 over I, over 1 plus I. All right. This will be x over 1 plus I times, brackets with 1 plus I plus I, 1 plus I, the power of minus n over, if you check this expression, we have the lowest common denominator, which is 1 plus I. So if you take 1 plus I times 1, it will be 1 plus I. Then minus 1 over 1 plus I. These two will cancel. We will have x over 1 plus I times, in brackets, 1 plus I to the power minus n, right? All over I over 1 plus I. So you will agree with me that I can actually take that term, this term, to the denominator. So we will be left with x into 1 plus I to the power of minus n, right, divided by, if I take it to the denominator, it will be 1 plus I multiplied by I over 1 plus I. These two will cancel if you agree with me. So we will be left with x into 1 plus I. Okay, over I. So this is the formula. Sorry, I made a very big mistake. It is not a plus, it is a minus. It is a minus. That's a minus, that's a minus. From the formula, guys, we all make mistakes. That's normal, that's a common error. We do make those mistakes. All right. Now, each and every time, whenever we talk about loans, this is the formula that you're gonna use. So, guys, I just wanted to derive these two formulas. Those are the two important formulas that we're gonna be using in our examples. So, guys, don't forget to like and subscribe. I will be back with more, and I will make sure that we do more examples in finance until you guys understand. Guys, don't forget to share, like, and subscribe. I'll see you on the next one.